Okay, everybody, your third CPM assignment for the week. We're cruising through this chapter. You guys are working hard. Keep that up. Your teachers are working hard. Thank them. And don't be afraid of bugging them. Remember, asking us questions is like giving us cookies, and everybody loves cookies, right? All right, we're doing CPM 2.3.3. Okay, so we can go ahead and get the easiest 3 points. It takes you about 30 to 40 seconds, right? And let's go ahead and put in who are we going to be today? Mr. October in November. Yeah, Reggie. Mr. October. He said a hot dog is someone who really kind of shows off a little bit, and he said, or someone once said about Reggie Jackson, there is not enough mustard in the world to cover that hot dog because he is such a big hot dog. But he got his nickname Mr. October because in the 1977 World Series, he came up to bat and hit a home run on the very first pitch he saw. Now, that's not that big a deal, right? But then a couple innings later, he came up to bat and hit another home run on the very first pitch he saw. And that is pretty amazing. But to add to that, he came up a third time in that game and hit a home run off another pitcher. So 3 different pitchers, 3 different pitches. He hit home runs, all 3, and it was in the World Series. So talking about rising to the occasion, he got the nickname Mr. October in November. So here we are. Sorry for taking so long to write those that easiest 3 points. We also want to add, I usually add as part of the heading if we're working out of the book, what are we working on? And we're doing lesson CPM 2.3.3. Now, some people say, Mr. Daniel, what page is that? Okay, the problem, why I don't give the page usually in this book is because some people are working out of the ebook. So I'm always giving the problem number. So it is, if you really want the page 84 and page 85. Okay, those are the page numbers. But we're doing problems 2-75. We're going to do all of them through -279. Okay, so 275 through 279. So make sure you don't write 275 and then 279 and not know that you're doing all the ones in between. If that confuses you, write them all out. 275, 276, 277, 278, and 279. All right, a lot of talk about that. Not getting enough work done. Sorry for the big old coffee stains in this. I think it's coffee stains. This is one of those books the librarian was not going to give a kid, so she gave it to me because I needed it. All right, methods and meetings. Don't forget, when you see methods and meetings, these are great things to copy into your math folders. Right? When you copy it, you're more likely to remember it, and then you have that written down in a safe spot. Okay? Now, if you've been doing our warm-ups faithfully like you should, these will look familiar and these will look easy. Okay? If not, I suggest you start doing these warm-ups, okay? Because I'm showing you how to do this stuff. So we're taking these generic rectangles, right? And it has missing numbers. Okay, so this one has 30 here and 1,500 there. 4 there. Don't be freaked out by that +4. Okay, if you've been watching our warm-ups, you've seen that I've been telling you that sometimes they do that. So here's what you're doing. You're saying 30 times 4 equals how much? And you're going to put that answer there. Now for here, we need to figure out what that number is, and same thing here. So what I do is I say 3 times what is 15? Well, that's 5, right? So this will likely be a 5 with a 0 because I have 2 zeros, right? Moved it over 2 spots. 30 times 50 is 1,500. Now I say 50 times what equals 250? And hopefully you are figuring out that is a 5. And now I'm going 5 times 4 is 20, and 30 times 4 is that and I put it in there, then I add these, right? So that's what I wanted you to do. Finish, it says solve the generic rectangle puzzle. So finish that. And I would recommend when you get done, multiplying using the standard algorithm and see if you get the same answer. Okay? Double checking is just a great habit. And you should always be curious if you got it right. And that's a good way of proving that you got it right. This next one, B, is one of those generic rectangles that has 3 columns, which means it's going to be 3 digits, right? Going off to the right. And I know it only has 2 rows, and this big box towards the bottom is 1,600. This is a 40. Then I have 2,400 there. I have a +7. Don't be afraid of the plus. And then I have a 56 here. So how do you do this? I'm starting with the fact that I know that's a 7 and that's 56. So I could say 7 times what equals 56. I'm going to give you a hint. It looks like a snowman. Okay? I'm also saying 40 times what equals 2,400. Okay? And to do that, there's 1 0 there. I think there's going to be another 0 there. Then I'm saying 4 times what equals 24. Hopefully figured out that is a 6. Okay? Now, once I figure out this, I could say this times what equals 1,600. And this times 60 goes here. Okay? Now, I think I gave you enough hints to get you started on that. If you're totally stuck, look in the ebook for more hints or come see your teacher. We'd be glad to help you. And again, hopefully you're doing those warm-ups. All right, 2-76. It says that James is painting a 10-foot by 8-foot wall that has a window that's 2 feet by 3 feet. And it says first to draw a diagram of the wall and the window, and then it says how many square feet of the wall does he need to paint. These are great area problems, right? It said square feet, so we know it's going to be area. So draw the picture of the wall. Most walls are rectangles, right? And it says it's 10 feet by 8 feet. And then it has a window that is 2 feet by 3 feet. Now, you're not going to paint the window, but you're going to paint everything else, right? So, what's the area that he needs to paint? Well, that's the area of the wall, and then subtract the area of the window. How do you get the area of the wall? The entire thing, that's 8 times 10. And that's going to be a certain amount of, remember, square feet, you can write like that, feet squared, okay, because to the second power is squared. And then the area of that window is just 2 feet times 3 feet. And that's also going to be feet squared. And then I'm going to subtract that from this, and then it'll give me my total, okay? So you go figure those out. Those are easy multiplication problems that you can do, okay? Now, 2-77, it says figure out whether each of the following pairs of fractions is a pair of equivalent fractions, and be sure to show all of your work or explain your thinking. So, we know, based on making equivalent fractions, that we can use what's called the magic 1. So, I'm saying if 1/4 is equal to 25 hundredths, then that means I multiplied it by 1. Okay, and I can start with the top or the bottom and say I multiply 1 by what number to get 25? It should be 25, right? Okay, so you put a 25 up there, and if this equals 1 and there's a 25 on top, what has to go on the bottom? 25. And is 4 times 25 100? Because if it is, I multiply both the top and the bottom by the same thing and got that, then yes, it is, huh? So we're going to say on that first one, A, yes. And that's why. How about B? Now we're saying 3/5 and 12/15. Well, if those were equivalent, then I would have multiplied the top and the bottom by the same number. It's like multiplying it by 1 to get 12/15. Right? So what do? You say 3 times what number is 12? And hopefully you guys know that that's going to be a 4. And if there's a 4 on the top and this is 1, I got to put a 4 on the bottom. And then you just check this 5 times 4, 15. No, it's not, is it? So that doesn't work. So that means this must not be. Okay, and we're going to say no. And I put in big red to make sure that that stands out. It is not equal. Huh? All right, let's squeeze this last one in here before we change the page and say 4/5 compared to 5/4. Now, I am not even going to get the magic 1 out of here because I know that this fraction is less than a whole. And I know that this fraction is bigger than a whole. So I'm just going to put a big, fat, not equal sign, and I'm going to put less than 1, and I'm going to put greater than 1 to show why I know that those are not equivalent. Okay? All right. Go to the next problem. 2-78. Okay? Now, 2-78 talks about base 10 blocks. And base 10 blocks are these blocks that you get. Okay? And that would be 10 by 10. So that's representing 100. All right? Then you get these skinny, and they're like rectangles, and that represents 10. And then you get these little single guys that represent 1, and those are base 10 blocks. Okay, so I always just think that's like $1, that's a dime, that's a penny. Okay, tens, ones, and hundreds. And then so the question is, Misty and Yesenia have a group of base 10 blocks. Misty has more blocks than Yesenia. Yesenia's blocks represent 17. So let's write that. Yesenia equals 17. Okay, and together they have 22 blocks. Okay, now 22 blocks is different than equaling 17. All right. Okay, total blocks equals 22 blocks. Okay. Now, the total number of blocks represent 85. $22 blocks. So what does that mean? Well, like you can have 3 10s and 3 1s. That's a total of 6 blocks that equal 3 10s is 30, 3 1s, right? So you can have 6 blocks equal 33 value, right? Because you got 3 10s and 3 1s. Make sense? Okay. Now Yesenia has 17 blocks. Yesenia's value equals 17, right? And the total value equals 85. Okay. And total they have 22 blocks. Okay. So what could each girl have? Okay. Misty, it does say Misty has 6 more blocks than Yesenia. Okay. Now, this is a puzzle problem. Okay. And I'm starting with the number of blocks first. Okay. This is total. 17 is Yesenia. Okay. So the value of Misty excuse me, will be 85 minus 17. The number of blocks is going to be 6 plus whatever she has is 6 more. So what if Misty had 10 blocks? If Misty had 10, that's 6 more than Yesenia. Yesenia would have 4. Does that add to 22? No. So she has to have more than that. Okay. What if she had 12 blocks? If she had 12, that's 6 more than Yesenia. Yesenia would have 6, and 6 plus 12 is 18. That's not 22, but we're getting closer, huh? Okay. Now, the big hint I'm giving you is I'm going to keep doing this and say, okay, what about if I go 2 more? If Misty has 14 and it's 6 more than Yesenia, Yesenia would have to have 14 minus 6, 8, and 14 plus 8 is 22. Okay, so 22 blocks is what we're looking for. Misty must have 14 and Yesenia must have 8, and Yesenia's 8 blocks make 17 for value, and Misty's 14 blocks is going to make this. Okay, now this is a fun puzzle problem. It's no fun to watch somebody do a puzzle, so I want you guys to go finish it. Okay, challenge yourself and see if you could figure out what's missing there. All right, and the last one, we have a golf tournament with the data below to all those. It says use that to make a dot plot, okay, and then create a stem and leaf plot, okay, and then use the stem and leaf plot to make a histogram. So this is a lot of good graphing, right? Remember a dot plot, it's going to look like this, and we're going to have all the numbers. Glancing at that, looks like I see a 25 might be the smallest, okay, and I'm going to have all the numbers all the way up. And what's the biggest one there? I see a 60. 63 is going to be the biggest. Okay. And so you're going to make the dot plot, 25, all the numbers all the way to 63. Wow. That's going to be a lot of work, huh? Well, it'll not hard work, right? But then a stem and leaf plot. The stem and leaf plot is when you're going to use stems, the tens place, 20s, 30s, 40s, 50s, 60s, right? And then put the leaves, right? So that 25 will be over here. Put a 5 on the stem of 2. The 63, you're going to put a 3 next to the 6, right? I would do the stem and leaf plot first. That might help me with that. And then the last thing you're going to do is make a histogram. Does it tell us what to do? Okay. I would make our histogram and use 0 to 10 and 11 to 20, 20 to 30, and 30 to 40, 40 to 50, and 50 to 60, and 60 to 70. And if you want, since there's nothing between 0 and 20, you can start yours at 20. I would do a little jagged line. Okay? All right. Good luck on that. If you need help, see your teacher. Otherwise, the answers will be posted tomorrow morning after they're due, right? Okay, you get help, Do it on time, you get a full credit. Otherwise, you wait and you can get all the answers given to you and turn it in late and lose a point or two.